Welcome in dark core. 10,000 light-years away, a star system is on the edge of self-destruction. V Sagittae is a binary system where a white dwarf is stealing material from its companion star. Astronomers have found it's consuming so much matter that it will eventually trigger a Type Ia supernova. When it happens, the explosion will shine as bright as the moon, so bright we may see it even in daylight. This rare cosmic event could happen within the next few centuries, maybe sooner. Until then, astronomers will keep watching this doomed star system spiral toward its spectacular end. Follow for more space updates. The Discovery event. V Sagittae has intrigued astronomers since its discovery in 1902. For decades, its unusual brightness puzzled researchers. Unlike most binary systems, V Sagittai's luminosity was disproportionately high for its size and distance. The breakthrough came when astronomers identified the culprit, a white dwarf locked in an extraordinarily close orbit with a larger companion star. These two objects circle each other roughly every 12 hours, an incredibly short period for a stellar system. What makes V Sagittae remarkable is the sheer violence of its interaction. The white dwarf, a dense stellar remnant about the size of Earth but with the mass of the Sun, is stripping material from its companion. This stolen matter doesn't fall directly onto the dwarf. Instead, it forms an accretion disk, a swirling ring of gas that gradually funnels matter onto the white dwarf's surface. Observations from the Very Large Telescope in Chile recently revealed a massive halo of gas around the system, evidence of how much material is being ripped away. This finding was key. The halo's size and density suggest that the white dwarf is consuming more matter than it can handle. The process is not stable. The system is brightening, and its motion has become erratic. According to researchers, this instability signals that the star is heading toward a catastrophic end. In short, V Sagittae is running out of time. Scientific importance and theories. To understand why this matters, we need to look at the role of white dwarfs in stellar evolution. Most stars similar to our Sun end their lives as white dwarfs, dense, slowly cooling remnants. Left alone, they fade quietly over billions of years. But when paired with a close companion, as in V Sagittae, they can become something far more explosive. When a white dwarf accumulates enough material, it risks surpassing the Chandrasekhar limit, about 1.4 times the mass of the Sun. Beyond this threshold, the dwarf can no longer support itself against gravity, triggering a runaway thermonuclear reaction. The result is a Type Ia supernova, one of the most powerful explosions in the universe. These events are particularly important in astronomy because they have a consistent peak brightness. They serve as standard candles to measure cosmic distances and help reveal that the universe is expanding at an accelerating rate. In V Sagittai's case, the signs suggest that the system is approaching such a fate. However, what makes it unique is the rate of mass transfer. The white dwarf is consuming its companion's material so rapidly that the system's brightness and instability appear unprecedented. Some researchers propose that we may first see repeated nova outbursts, temporary surface explosions as the dwarf sheds excess material. But eventually, as matter piles up, the system will likely cross the Chandrasekhar threshold and ignite a supernova. This potential explosion would not just be another distant event. At its peak, the supernova could rival or even outshine the full moon, remaining visible in daylight for weeks. Few astronomical events in recorded history have had that level of impact on Earth's skies. Implications and what's next? The possible future of V Sagittae raises both immediate and broader questions. For Earth, the good news is that the system's distance, 10,000 light-years, is far enough that the explosion will pose no danger. The radiation and shock wave will dissipate long before reaching us. What we will witness instead is a spectacular celestial event, a once-in-a-lifetime sight that will redefine how we perceive the night sky. Scientifically, observing V Sagittai's progression provides a rare laboratory for understanding stellar death. Unlike most supernova candidates where predictions span thousands or millions of years, V Sagittae appears to be on a much shorter timescale. Some models suggest its final outburst could happen within the next few decades, though predicting an exact timeline remains challenging. Even if the supernova is centuries away, the system's increasing brightness and activity will offer valuable data for years to come. The implications extend beyond astronomy textbooks. Supernovae like the one expected from V Sagittae play a central role in cosmic recycling. They forge and distribute heavy elements such as carbon, oxygen, and iron that later become the building blocks of planets and life. In this way, every supernova connects to our own existence. Studying this process as it unfolds could deepen our understanding of how elements spread through galaxies and seed future generations of stars. There is also an observational angle. Other galaxies contain binary systems similar to V Sagittae, but most are too distant to study in detail. Having a nearby example gives astronomers a benchmark for interpreting distant supernovae. This is particularly important because Type Ia supernovae underpin much of modern cosmology, including measurements that reveal dark energy. Watching one in the making could refine our models and improve the precision of those measurements. What happens next will depend on continued monitoring. Telescopes around the world, and soon, next-generation instruments like the Vera Rubin Observatory, will track V Sagittae closely. Scientists will be looking for signs of nova outbursts, changes in brightness, or shifts in orbital dynamics, all potential precursors to the final explosion. The hope is that by observing these changes in real time, astronomers can establish clear indicators of when a white dwarf is approaching its breaking point. Outro. V Sagittae is a rare chance to watch a dying star system in real time. Its eventual supernova will light up Earth's skies without posing a threat, a reminder that even fixed stars are part of an ever-changing universe. Thanks for watching Dark Core.